and welcome to Algebra 2 with Mr. Clausen. Today I'm going to go over some basic calculations with trigonometry. And specifically what I'm going to do is I'm going to look at how to measure angles in standard position. I'm going to look at how to sketch angles in standard position. We're going to go over some basics of how to calculate the sine and cosine of an angle in degrees, and then also converting degrees to radians and vice versa. And at the end of the video, I'll go over how to switch from radians to degrees in your TI-84 or Desmos technology, which will relate to skill 3 if you are having any problems. So to get started here, I want to look at how to measure angles in standard position. And one of the first things I want to go over is looking at the unit circle. And if we want to measure the angle of a unit circle, the first thing that we usually take into consideration is what quadrant is the angle in. And in this given case, everything's going to start with an initial side right here. So this will be our initial side, which is just at 0 degrees, which is the beginning of quadrant 1. And after you cross the y-axis, you get to quadrant 2, and you cross into the third quadrant here, and then you have quadrant 4, and once you go full 360 degrees, the function repeats again. And we'll try to get into the details as we progress into these videos as far as how this works, why we call trigonometric functions periodic functions, and that they're one and the same. But for now, I want to just get into basic terminology here so that we can kind of explore and talk about this a little bit. Now, if we're looking at an angle like this, what we want to be able to do is we want to be able to go analyze it and determine the types of angles that are present here. Now, we're not measuring it in terms of, what is the specific measure. In a typical problem, what you would have is you have an angle identified like this, and then they would tell you something. They would go and they would say, for example, that the angle represented from here to here represents something. Now, this angle I'm going to say is 45 degrees in this particular instance. And this is just the standard angle measure. This is the angle measure based on standard position. All right. And so this can be useful for a number of different reasons. One, it could tell you relative position along the circle. If you want to know the length of an arc, you can find the length of an arc. Anything that you can apply a right triangle or a circle to, you can use trigonometry and find different things. But in order to do that, we have to be able to analyze basic angles. So if we have an angle here and we say that angle theta is equal to 45 degrees, we're just representing this angle here. Now, when we go and we evaluate this, we're always starting at 0 degrees and seeing how far it goes into a particular quadrant. So whenever we're looking at an angle, this is just our regular angle, but there's also something referred to as a coterminal angle. And the coterminal angle is going to represent this same line here, but it's just going to be represented in the other direction. So if you ever want to find a coterminal angle to say, 45 degrees, what you do is you just go, well, what happens if we go the other way? And how many degrees would you have to travel in the opposite direction to get here? And if you ever want to find a coterminal angle, you just take the regular angle or the terminal angle. You just take the terminal angle and you subtract it by the coterminal angle. And if you take the terminal and subtract it by the coterminal, you should always get 360 degrees. So if this is 45, 45 minus, let's say, 315 would give you 360 degrees. So the coterminal angle for this would be 315 degrees. And it'd be negative because we are going clockwise on the unit circle. All right. So it's just some things to kind of keep in mind as you're going through and we're trying to look at and analyze this behavior. So remember, entire circle is 0 or 360 degrees. Terminal angle, coterminal angle, and we can go and look at some of this behavior. And so let's say, we have this here and we have a little wedge that goes and says, hey, we have this angle here, and we'll say that this is 30 degrees, this little wedge right here from this point to this point. And we want to know the angle measure here based on standard position. Well, the standard position, again, is just describing that this is the initial side. And the initial side will always be at 0 degrees. And so if we want to know the measure of this angle in the positive direction, what you should know is, if we go in the positive direction or the counterclockwise direction, we know half of a circle, just based on our intuition, is 180 degrees. And if this is 30 degrees here, the sum of both of these would be the regular terminal angle. So the terminal angle, 180 plus 30, would simply be 210 degrees. So if we are looking at this particular instance,
18 more days of school. Did you realize you can go 5 by 3 plus 3
all right, so if this is 180 degrees and this is 30 degrees, we can take the sum of 180 plus 30, and that would equal 210 degrees. And this would be just simply our angle measure, our terminal angle. And so if you know the terminal angle, the coterminal angle is just the angle in the other direction. So I would do the same type of math here. If I want to know the coterminal angle, which is the angle that goes in this direction, all I would need to do in this particular instance is just simply say, hey, it's 360 and 210, it's that difference, or we could say 210 minus 360, and I would simply say that this is equal to negative 150 degrees. And you can do that in a few different ways. You just know that it will always have the opposite sign, and then the sum of the two numbers would have a magnitude of 360 degrees. So what I mean by that is if you go the terminal angle, plus the absolute value of the coterminal or something of that nature, then this would equal 360 degrees, just to give you an example. And so let's look at one other instance here. So let's say, for example, they tell us that the angle, of this, it wraps around, and let's say they tell you that this is equal to 480 degrees, and they want you to come up with the terminal and coterminal angles. Well, you can always figure out the standard position angle by whatever this distance is. When they say standard position, they just want to know, hey, what is that angle? Well, if you want to figure that out, you see that this takes a whole cycle before it comes full circle. So, it's just like snowboarding. If you go and you do a 360, you made one complete circle. If you did a 540 on your snowboard, you are going down the hill backwards now, or you got to reorient your body or something like that. So the same thing can apply in a periodic function, is that it'll repeat itself and you'll have these different circumstances. So if you want to know this position in standard position, you can simply go 480, and then you can subtract it by as many 360s as you need to get a new number between 0 and 360. In this case, it'd be 1, and then you have 120 degrees as your terminal angle. And if you needed to know the coterminal, you just go this way. You'd go 120 minus 360, and you get negative 240. All right, and so these are just some different angle measures that we can find and identify in these given circumstances. So let's look at how to sketch some of these angles. So, if I'm told, hey, your angle's negative 130 degrees, well, I'm going to have my standard initial side, and since it's negative 130, I'm going to go opposite of the regions 1, 2, 3, 4. And so what that means, I'm going to go 90 plus 40. So I'm going to go and do something like this. This will represent my negative 130 degrees. And again, we're just trying to get an idea of, hey, this is what this angle represents. This is how you can draw it. Now, if you're told, for example, that you have, say, 230 degrees, and you're told that's your angle, you're going to draw the exact same thing, except that you would go 230 degrees in the standard direction, and it would represent the same angle measure. Okay, so I'm just getting you used to some terminology here. The same thing would occur here. All right, so let's say this is your initial sine. You go 360, all right, plus 8 plus 25. Okay, and so if we're looking at this, know that this little squiggle here, this wraparound, is your 385 degrees in the positive direction. But remember that we're just going to subtract as many 360s as we can until we get a number between 0 and 360. And this would equal 25 degrees. All right, and so this little part's 25 degrees. And then we could just draw it like this. And this is how you can just simply sketch an angle in standard position. We'll do the same thing at 500 here. Remember that you start with your initial side going in this direction, just like this at the 0 degree mark. You know, and then you have 1, 2, 3, 4 in terms of your angle measures here. And now we're going to go 360. All right, and we would have 140 left. So we'll go 90 plus 50. And you would get something sort of like this as your angle for 500 degrees. Now we'll do the same thing. We'll subtract 360 as many times as we need to. We'll only need to do it once. And so we'll get, 140 degrees remaining. So this angle measure here is 140 degrees. Or if you want, we could go this way and we could say, negative 220. And all these would represent the same thing. So if you accidentally subtracted 360 from it twice to get a number between 0 and 360, you could do that. But all of these will represent the same thing. So as you're going through, you're going to practice just sketching some angles. You're going to practice identifying some angles. You're going to practice identifying some coterminal angles and looking for some of these different things. Now let's look at how we can calculate some of these. So this specific angle here, I'm just going to tell you what I have as far as a representation here. So here I have a situation where we have, let's look at this one first, where we have this angle. And let's say that this angle is equal to 115 degrees. All right. And so that would mean that the coterminal angle would be equal to negative 245 degrees. And what I want to point out is if we want to calculate the sine and cosine of an angle, what we're going to assume is that the radius of the circle is equal to 1. So the distance from the origin to the circle is equal to 1. And what the sine and cosine tell you is the sine and cosine tell you what the y and x value is for a particular point on a circle. So if the origin of the circle is here, and I say, well, let's calculate the sine of y for this given point here. Well, the sine of y tells you what the y value is of this coordinate pair. So if you have x and y as a coordinate pair here, well, the sine function of theta, assuming that this is either one of these angles is theta, will give you the y value for this specific point, and the cosine of theta will give you the x value, or the horizontal distance from this given point. All right, so it's just Pythagorean's theorem all over again here. But if we go and we say, all right, what's the sine of 115 degrees? All right, what you'll see is that it just tells you it's 0.906. If you get a number different than this, don't worry, just go to the bonus skill at the end of the video and I'll explain how you switch back and forth. But if you go sine of 115 degrees, it'll give you 0.906. The really cool thing about periodic functions is that if we go negative 245 degrees, it represents the same thing, right? So you should get the same value. And hey, guess what? If you plug it in your calculator, you get the exact same value, all right? And if we want to go cosine of 115 degrees, it's the exact same thing, except that you'll get negative 0.2 or 423, which makes sense, right? We're going in the negative direction by negative 0.423, in the positive direction 0.906, which seems pretty reasonable if the radius of the circle is 1. And again, if we go cosine of negative 245 degrees, we will get the same value of negative 0.423. All right, and so it just kind of gives you some ammunition here to go and figure out some of these given values and see what is going on here. So another example that I'll just go over super briefly is, let's say this is 45 degrees here. Well, the cool thing about 45 degrees is, you know, that's exactly 1/2 of 90 degrees. So you would expect change of x here to be exactly the same as change in y here. So you can think about it as this right triangle, and if you're told that this is theta, cosine of theta tells you the horizontal distance, sine of theta tells you the vertical distance. And so let's plug this into our calculator. If we go sine of 45 degrees, you know, and you plug this in, okay, you'll get 0.707 as one of your values. And then if you go cosine of 45 degrees and you plug that into your calculator, you'll again get 0.707 as your value that pops out. And that's just how you would evaluate it and plug it in. So go ahead and try this. If you don't get these numbers, go to the bonus skill at the end of the video and then you'll see how to do it. So the last skill I want to talk with you about is skill 4. And this is just converting degrees to radians or vice versa. And so we'll get to how we use some of this, but right now I just want to expose you to this idea of how to switch back and forth. Because if we talk about what a radian is equal to 180 degrees. And you guys know that 2 pi is equal to 300 degrees. This has been truth since the end of time. So what all this means is that if you have 360 degrees, you simply know that if you divide that by 2 pi, this is equal to 1. So if we simplify that out, we understand that this is a 1-to-1 ratio. So pi radians divided by 180 degrees can be used to switch degrees to radians. And 180 degrees divided by radians can be used to convert radians to degrees. And so I'm just going to go over a couple examples and show you how you can do this. So if you want to take, like, let's say 150 degrees and you want to convert it to radians, all right, let's say we're measuring the arc of something, which is something I'll show you in a future video. What you can do is just say 150 degrees, put on the bottom what you want to cancel, put what you want on top, and we just start looking at some of the ratios here. You can see that if we simplify this out a little bit, we can see that 30 goes into 155 times and goes to 186 times. So we can simplify that out, and we just converted 150 degrees to 5 pi over 6 radians. And we have this new value. Same can be done with negative degree values. Say we have negative 60 degrees. Again, we're going to do the same thing, 180 degrees to pi radians. Degrees is on the bottom because that's what we're going to cancel. 60 goes into 180 3 times. And get your answer of negative pi over 3. And if you can't do it that fast in your head, that's okay. Like, you can use your calculator and use your fraction to decimal changer tool, and it'll go and it'll figure out some of that stuff for you. Now, the last example that I want to look at is how to convert a radian to a degree. Okay, and it's going to be the exact same thing, but keep in mind, since pi's here, I know that my functions in radians, or my values in radians. So I want to stick pi radians on the bottom and then just convert that to 180 degrees. Okay, so I'm looking at the opposite here. I see that 10 goes into 180 18 times. So I'll just simplify that out a little bit. 11 times 18 will be equal to 198. All right, and I have the degrees there because the pi's, or radians, are going to cancel. And then that would be my new value. So this is our bonus skill video portion here. And what I want to show you is that if you were doing skill 3 in this video and you were getting different values than I was getting when you're computing things on the calculator, I want to go over real quickly why that is. So with trigonometric functions, there are two common units that are used. There's degrees and there's radians. And so if you go and you want to evaluate something like the sine of 115, right, your calculator doesn't necessarily know whether that's radians or degrees. You have to tell it what it is. And if you get a value like 0.9454 or something like that, it is currently set up to read your value in radians, all right? And both of these types of values are very practical, but the main difference is that if you are dealing with degrees, you are trying to analyze the angle of something, and if you are looking at the arc of something, then you want to look at radians, which we're going to talk about in a little bit later video. So if you need to switch this, what you do is you go to mode, you toggle down to where it says radian, you switch it to degree, you select it, you exit out, and then you go and you evaluate that function again. And what it'll do is it will give you the 0.906 that you were looking for previously. Now, if you need to go and do this in Desmos, what you can do is you can do the same thing. You can see I have the 0.906 here. So what you're going to see here is that if you have sine of 115 degrees, we see that it's in the value that you have now. Now, if you need to switch back, what you do is you just simply select settings, you switch over to radians, and then you can get your new value or switch back to get it in degrees. So that's how you switch back and forth between radians and degrees, and I hope you found this video helpful, and let's do some math.